Alright, so this video is on the 6K handout, which by the way is section 6.4 in your in your textbook, so I'll put that up here. In textbook. Alright, so we've actually talked a little bit about this stuff in passing first semester. And so I'm not really going to go through it in a ton of detail, but if you think about a triangle, let me draw an exaggerated one. If this is the biggest angle in the triangle, then it opens up to the biggest side in the triangle. And if you have a small angle, then it opens up to a smaller side in the triangle. So the bigger the angle in a triangle, the bigger the side that it opens up to. So let's look at number one. Number one, we have a triangle with 3 sides. And so I'm not going to bother drawing things to scale here. We're just using this as a reference. So AB is 9, AC is 10, and BC is 12. And the question is, which angle is the smallest? Well, in this one, the smallest side is 9, so the smallest angle is going to be angle C. So the smallest angle, angle C, because it's opposite the shortest side. And then using the same kind of logic, the 12 is the longest side, so that's going to be opposite the biggest angle. So the largest angle is angle A, because it's opposite the largest side, or the longest side. Okay, if we look at number 2, I'm not going to bother drawing it to scale, although it's not too hard to do that. Let's say RST. R is 90 degrees, S is 40 degrees, and T is 50 degrees. And the question is, well, which is the shortest side? Well, here's the smallest angle. That's opposite the shortest side. So shortest side is RT because it's opposite the smallest angle. And the longest side is going to be opposite the biggest angle, so that's going to be ST because opposite the largest angle. Okay, number 3, we've actually talked about this before too. Shortest distance, or the shortest segment from any point to any line is, well, let's draw them in. So in this one right here, the shortest distance from this point to this line isn't going to be something that's kind of like off in the distance there. It's going to be the one that goes straight to the line as quickly as possible. And then in this other example right here, it's going to look something like that. Oh, let me do that a little bit better. Like that. And the key to these is that they form right angles, right? So shortest segment is perpendicular to the line. Okay. In number 4, so this was related to a previous homework problem. There's a theorem that says the sum of the length of any 2 sides of a triangle is greater than the length of the third side. Okay, so it turns out that you can use that to check if you can form a triangle with 3 side lengths. You just check all the combos of 2 sides and compare it to the third side every time. So when I say, can a triangle be formed with lengths 10, 14, and 20, you're going to check, are the sum of the first 2 sides greater than the third side? And in this case it is. And then you check all the combos of 2 sides. So instead of 10 and 14, let's try 10 and 20. And then check, is that bigger than 14? And yeah, 30 is bigger than 14. And then we check the other combo, 14 plus 20. Is that bigger than 10? And yes, it is. And so then we can say, therefore, a triangle exists because no matter which 2 sides I pick, those 2 sides added together are always bigger than the third side. In the next one, if I try it, we'll try 17 plus 22. Is that bigger than 5? And yes, 17 plus 22 is definitely bigger than 5. Let me try 17 plus 5. Is that bigger than 22? and no, it's equal to 22. So because of this one, we can say, therefore, the triangle does not exist. D and E, by the way, does not exist. Okay. You could keep going, but once you find one thing that doesn't work, then the whole triangle can't exist. Now, there's a shortcut for this. You don't really have to check every single combination here. What you could do is just check, do the two shorter sides add up to be bigger than the longer side? Because if you think about it, like in this problem here, if I just lay down the 22, the long side is on the ground, and then I think about, well, I'm going to connect the 17 to this side and the 5 to that side. Well, 17 here, 5 here. The question is, will they actually be able to meet up? Well, 17 plus 5 is 22, so the only way they'd meet up is if they were lying right on top. Whoops, sorry. Right on top. So like if this is the 17 here, right there, the 5 would have to also be lying right on top of the 22. So you wouldn't actually get a triangle, you just get this flat shape. So 17 plus 5 is less than 22 or equal to 22. You're never going to get the triangle. Okay? So let's take a look at number 5. So 5 talks about that shortcut. Just think about the long side. That's the most important part. So if I put down the 15, the question is, can I connect the 6 and the 7 if I put the 6 on this side and the 7 on that side? Well, if you think about it, 6 plus 7 is only 13. So if I put the 6 here and this, whoops, 6 would be shorter. So if I put the 6 here and the 7 here, there's no actual way to connect them because there'd always be a gap between them. 6 plus 7 is not greater than 13. No, so triangle does not exist. Okay, in this one, the long side's 40. So then all we're really checking is if I added 20 and 21, do I get at least 40? And yeah, 41 is bigger than 40. So triangle does exist. Notice this is a little bit quicker. I don't have to check every combo. And if you think about it, lay down the flat side, 40. Well, 20 over here and 21 over there would be able to meet because they add up to be longer than 40. Now, it turns out if you actually drew this accurately and try to connect them, this would be a super flat triangle because 41 is just barely bigger than 40. So it'd be, something like that, and probably even flatter looking than that. Okay, in 6, two sides of a triangle have length 15 and 20. So let's see here. So and so the question is, what's the possible lengths for the third side? So if you think about it, if I put like the 20 down here, and then I connect the 15 to it, right? Now kind of picture the 15 as swinging around. So I could put it at a right angle right here. Or I could swing it down this way so that it's like right there, 15. Or I could swing it this way so that it's way out here, so that this is 15 instead. So if you kind of picture that the 15 is almost pointing the exact opposite direction as the 20, as long as this isn't exactly 180 degrees, because if it was, then it'd be a straight line, so you couldn't make a triangle. If it's a little less than 180, then you could connect this end to this end and get a little triangle there. Now, if you think about it, this is just less than 15 plus 20. Or let me do 20 plus 15. I realize that doesn't really matter, but let me write it let me put big number first. Just less than 20 plus 15. If it was actually 35, then you'd have a flat triangle. Okay? If I do the same sort of thing, but I move the 15 over to the other side, so now the 15, instead of going out this way, is going to go inwards. So like that. 15 right here. Okay, then the question is, well, what's left over to finish off the triangle? Well, you can kind of picture that this is going to be a little bit longer than 5, because 15 plus 5 will give me 20. So this one is just longer. Whoops, longer than 20 minus 15, the long minus the short, right? So the third side, the way I'm going to write this up, the third side has to be between 20 plus 15 and 20 minus 15. So that leaves us with between 5 for the third side and 35. So number 7 is basically the same problem here. So 7, instead of drawing this out, I'm just going to say, well, we know that the third side is going to have to be between 12 plus 8 and 12 minus 8. So the third side will be between 20 and 4 units long. Okay, so for number 8, 8's actually a related problem. We have a parallelogram and the lengths are 10 and 12. So what are the possible lengths for the diagonals? So if I just start out with a parallelogram like this, let's say this is 10 and this is 12. Well, here's one diagonal that's kind of long, and you might be able to picture if I were to pull out on these corners. Imagine that the corners are, you can kind of pull out on them. You can't change the lengths of the 10 and 12, but you can change this diagonal here by pulling out on those two arrows on those corners. Then you would end up with a picture that looks, here, I'll color code it. So let's make the 10s red and the 12s blue. Blue and blue. So if I pull out on the corners, you can kind of picture that that parallelogram gets flatter and flatter. And really what's happening here is I'm just going to draw a super flat looking parallelogram. So there's the 10. There's the 12. And then you get the same thing going underneath, right? Here's a 10, and here's a 12. And here is the long diagonal. Well, if I erase this, whoops, you can kind of see that this is essentially the same type of problem we were working out before. What's the longest side of this triangle that you can get? Well, that's 10 plus 12, or I'll do 12 plus 10 there. 12 plus 10 equals 22. So you know it's going to be a little bit less than 22. Okay. Now if I squeeze these together instead, then you'll get the shortest diagonal possible. So if I do that, then here it's going to look more like this. So here's the 10, and here's a 12, and here's another 12, and here's another 10. And so the short diagonal goes from here to here, right there. Now if I erase the bottom, whoops, this is basically saying what's the shortest third side you can get for a triangle with sides of 10 and 12. And we learned, well, you take the difference. So this, I do not know what just happened. There we go. Let me make sure it's still recording. Yeah, okay. So this right here is going to be 12 minus 10 equals 2. It's going to be just less than, or just greater than that. So more than 2 and less than 22. So we'll say that the diagonal has to be between 22 and 2. All right, so we have two last problems here. One is comparing angles and the other is comparing sides. And so let's fill in what we have here first. So if you notice, this is parallel to this and this is parallel to that. So we've got a parallelogram here. So that means that this side, JO, is going to be 15 because this side was 15. And then really all you have to do is examine this triangle right there, because we know all three sides. 14 is the shortest side, so this is going to be the smallest angle. And notice these are greater than symbols, so the smallest one goes here. So X goes there. Let me write that a little bit better. X. 15 is the medium length side, so that opens up to, or angle Y opens up to the 15, so that's the medium angle. And then 24 is the longest side, so that opens up to Z. So Z is going to be our smallest, or our largest angle. Ooh, sorry about that. Okay. And then in number 10, it says order the sides from shortest to longest. Well, first we need to find the missing angles. So 65 plus 55 is 120, which means I'm left with 60 degrees in this triangle. If you did the same deal down here, well, let's see, that's 3 less than 60, so I need 3 more than 60 left over for the one remaining angle. So this one's 63. And now let's go through the first triangle, ABC. Let's go through ABC. 55 is the smallest angle, so this is going to be the shortest side for ABC. And then the medium side will be up here at AB. And then 65 is the biggest angle, so BC is the long side for this triangle here. Okay. And then in the other triangle, this one, the 57 is the smallest angle, so this is the short side. And then the 60 is the medium, opens up to the medium, and the 63 opens up to the longest. So I've got two short sides. I've got AC and I've got BC. But if you look at BC, BC is the short side of the blue triangle, but it's the long side of the green triangle. So anything in the blue triangle that's bigger than BC has to be bigger than any green side. So the shortest side is going to be AC. And then we just work our way up. So AC is shorter than AB, which is shorter than BC. Whoop. So that's the long side of the green triangle, which is the short side of the blue triangle. And then I just keep going with blues. So I go short, then to medium, and then to long. CD. So there we go. I hope that helps a little bit.